So 4.6, sum and difference of cubes. So no longer square, yes, cubes. But remember, your calculator does know cubes and cube roots, by the way. But here's a list of perfect cubes. I've got up to 125 memorized. After that, I refer to a list or my calculator. But if you can get the first 10 memorized, again, it just kind of speeds up this process of perfect square or cube stuff that we're doing here. Yeah, sum of two cubes. If you see that the two terms, so this would be like looking at a binomial again, but now they're cubed instead of squared. We end up with this kind of expression right here, okay? So if it's plus, you got a binomial with plus, and then by the way, the last operation is always addition, but you see the plus and the minus, they just alternate. So for plus, it's plus minus. For minus, it's minus plus right here. I'm sure there's gimmicks on how to memorize how this formula is. I just don't have any, so, but you're welcome to look up any YouTube videos that do. Again, for me, it's just noticing that the perfect cubes first, because if you can, then everything else kind of just falls into place usually anyways. So at the end, you could also check, right? You could actually distribute in each of these terms into the trinomial, and then it should simplify back into your binomial right there. There's reasons why this worked, but I also assume you don't care. So on this one, we see x cubed. Again, if you wanted to notice that it has a coefficient of 1, that's fine. 1 is its own perfect cube, which is great, but we don't need it. Okay, hopefully we don't need it. Now is 64 a perfect cube? Yeah, it is. It is. So, yeah. So I'm going to write this. I know my a then is x cubed, and then my b, 64. You can cube root it in the calculator again if you need it, but again, I got to memorize, so I know that kind of gives me that's a cube, by the way. 4 cube. Now, if you want to make a list or have a calculator, especially when you're doing the assignment, just do it. But on the, we see this kind of stuff on an exam, you'd have to use a calculator for it. All right, so at the top, I look and I see this is a plus of cubes. So I know that my two terms, the first binomial will be plus, and then it will be minus, and then plus. Here, okay? All I've got to do is fill in everything else at this point. I know the middle term, a times b, we'll take care of that, but first one is x. Let's fill in all the a's, in fact. So I've got my a's here, here, and here, and then I've got my b's here, here, and here. Now don't forget, because I almost did, that these two are squared, like this. So yeah, don't forget to look at the formula for that if you need it. Yeah, so that is the reason why that is important, is because like I can't do anything else with the rest of this stuff, but yeah, the 4 squared, I do need to show that as a positive 16 right there. And then this is actually our final, yeah, this is our final expression right here. Now this one works out nice because there's only one x, there's the x cubed, right? But do be prepared, because the 64 perhaps may have like a y cubed. Okay, and then you get x's and y's in like here and then here and then here. So expect it, it's probably gonna happen. All right, so on this one, yeah, now it's a minus, right? So I'm expecting this to be minus plus plus, or we get a minus in the binomial, right? However you wanna say it. But again, we do know that 64 is a perfect square, and 1 is a perfect, sorry, I said perfect square, it's a perfect cube. So I'm gonna set up my difference of cubes right here, okay? So we got, we'll have minus there in the binomial, and then in my trinomial, it'll be plus plus. Okay, so I'm just setting this up so that I can fill this in as we go. Looks like I guess I'll need to actually do some work after we fill this in. But to start out, I got the 64x cubed, which is something cubed, and 64 cube rooted is 4, and then the x is just, x cubed would just be the x. Okay, so my a value is 4x, and again, you could fill this in right now if you wanted to with your a's in the difference of two cubes. I'm going to call it a formula because that's kind of what it is. But don't forget your squares on the first and last terms. I almost did it again. Yeah, this is going to be a 4x here. Yeah, I'll even put it in parentheses just to kind of specify that. And then it's part of the middle term there as well. So I filled that in, and we'll finish evaluating those or simplifying those later. But the 1 as well. I don't care about the minus sign, but the 1 would be 1 to the power of 3. So there's a 1. There's a 1, and if you want to show the multiplication, that's fine. Then we got the 1 squared, right? All right, from here, though, this can be simplified. So let's simplify that a little bit. Not the 4x minus 1, right? That's going to have to stay. But some of the rest of this stuff needs to change. The pluses aren't going to change. That's not going to change. But yeah, 4x to the power of 2. You've got to square both those. So 4 to the power of 2 is 16. And then x squared, x to the power of 2 is just x squared. So that's my first term there. 4x times 1 would be just 4x. And then 1 to the power of 2 is just 1. So you can see sometimes, especially if we do have a coefficient of x cubed here that's not 1, yeah, you may have to do some multiplication or squaring, especially inside the trinomial there. But that's it. We did it. It does make it convenient when it's just rule-based like this. So again, this one, 8 is a perfect cube, 125 is a perfect cube, x is a perfect cube, y is a perfect cube. So I'm expecting a difference of cubes right here, which again, I'm just kind of looking at the formula there for my difference of cubes. I got minus in the binomial and then addition in the trinomial. But we do need to figure out our a's and b's on this one. So of course the x and y's are going to work. So the x is fine as a cube. But 8, that would have been 2 cubed, right? So let's fill in our a's. So there's a 2x there. Oh man, I did it again. I need my squares in these. And then we got a 2x, a value there, and then even here. Now, I'm putting this in parentheses because I'm expecting more from the b value this time. And yeah, 125, yeah, is 5 to the power of 3. And then y is just y to the power of 3. So I end up with a b value that's 5y. And again, our binomial, there's nothing else to do there. But I got to fill in the rest of it, right? So there's my 5y, which we will square. But I got to put it here as well. Okay, so simplifying this, of course, our first binomial, it's going to remain the same. Okay, now in this other set of parentheses, none of this is going to affect the plus signs there, but 2x to the power of 2. 2 to the power of 2 would have been 4. X to the power of 2 is just 2. Now the middle one as well, we got to do some multiplication there. 2 times 5 is 10, and then we can just tack on the x and y. And then finally, here at the end, 5 to the power of 2 is 25, and then y to the power of 2 is just y to the power of 2. And we did it. I'll reiterate this in the video, but the minus sign right there, I don't really care about it. All it does is tell me if I got minus and plus here. Because if it was plus, then I'd have plus and minus. Either way. So on this one, sometimes students see that the 2 is not a perfect cube, and they're like, it's done, it can't be factored. It's just that you can factor out a greatest common factor first, right? Which is something you should always look for. So that's what we're going to start out with on this, is just let's factor out the 2 and see what's left over there. Okay, so if I factor out a 2 from the first term, I think I'll put red there. Then I got x cubed as my first term. And then the plus sign stays, but 128 divided by 2 would be 64. And 64 is a perfect cube, so this is going to work out. And now, again, I'm not worried about the 2 yet. We'll come back to it. But let's look at just I guess this is the sum of cubes. So we're going to do sum of cubes with our binomial and trinomial. It's plus, so I'm expecting addition in the binomial, and then would have subtraction and then addition in the trinomial. Okay, but what are our a and b values here? Well, a, right, we want to find something that's cubed for both. A is just it's just the x. Don't forget your squares there, by the way, which I almost did. So there's one of the A's, there's another one, and I'm kind of purposely putting the X to the right here just so it looks maybe a little bit better. And then 64 is 4 to the power of 3. So I've got a 4 wherever there should be B's in the formula there, right? So this one's pretty close. There's not a whole lot of simplification to go on here, evaluation. It's the 4 to the power of 2 there. 4 to the power of 2 is 16. So we'll write it as 16, which is, I guess it's better. Oh, see, I almost did it. I almost forgot the 2 at the end there. Don't forget that 2 that was there to start with. Now it's good.